Now that we have looked at binary numbers, we are going to look at how we can use those binary numbers and those signals to transmit data to and from your computer. So remember the electromagnetic spectrum and that energy travels in waves. So let's review a few things about waves at this moment. Electromagnetic waves are transverse waves. So we are going to specifically talk about the transverse waves today. Remember that amplitude is how tall a wave is or how deep it is. So it's the height from the equilibrium point to the crest or the depth of the equilibrium point to the trough. Frequency is the number of waves per second. So if you stand on a dock and you watch 4 waves go by in 1 second, your frequency is 4 hertz. And then one that we haven't talked about is called phase. And this is where you are along the sine wave. So this is if your wave has shifted in any way. So when we say the 0 point of our wave, that's where our wave starts, right? So we go up and then we go down, and then we come back to that 0 point again. If we were to take our wave and start it there at that 90 degrees, we would call that a 90 degrees phase shift. So that is where our wave would go up, and then it would come down at the 270 and come back up a little bit past that 360. So we would say that our wave has shifted 90 degrees. If our wave shifts 180 degrees, then it starts there. So instead of going down, our wave would be going up, and then it would come down through the 360 and up another half a wavelength past that. So we're not going to get into a lot of what that actually means in terms of the math, but just know that it's the wave is shifting along its starting point. So when we change a wave, we call that modulation. So we have this nice signal wave, and then we can change the amplitude or the frequency or the phase to be able to carry information. And you've probably heard of these. Amplitude modulation is your AM radio. So what we're doing is we're changing the amplitude of the wave. Frequency modulation is FM on our radio dial, and we're changing the frequency of our wave. So the modulation just means that we are changing the wave to carry data, and the amplitude means we're changing the amplitude, and frequency means we're changing the frequency. So when we change our wave to carry data, we call this shift keying. And this is making the wave able to carry information in a digital manner. So those waves coming from your Wi-Fi hotspot and traveling to your phone are encoded. So digital signals are represented by bits. So that on or that off, that 1 or that 0. That's how we carry our information. Now remember, those bits do not have to be 1s and 0s, and they're actually not 1s and 0s. The 1 and the 0 is just a way that we can represent the on or the off. So if we have a high voltage, we would represent that with a 1. A low voltage, we'd represent that with a 0. If we have a high amplitude, we could represent that with a 1. A low amplitude could represent a 0. So the 1 and the 0 just represents whether or not that information is on or off for that interpretation by the computer. Now, amplitude shift keying, what we're going to do is we're going to change the wave by a really abrupt change in our amplitude. So if we have a really high amplitude followed by a really low amplitude, that's the change in the wave, and that's going to represent that binary bit. So for example, we have the letter A. We look up the binary representation of the letter A. We find it to be 0, 1, 0, 0, 0, 0, 0, 1. Okay, that's our binary A. And we can represent that with a binary wave. Binary wave is just a square wave. So think about our wave, we're just blocking it off. So a 0 is a low trough, and a 1 is a high crest. And it's just flat. It's not really drawn as a wave, it's just drawn as a flat line representation. So for A, we would have a trough, a flat line trough. We would have a flat line crest. And then we would follow that with 5 flat line troughs and a flat line crest. Now for an amplitude shift key, we are going to represent those troughs and those zeros as a low amplitude. So if we look in this column, the 0 is going to be represented by the low amplitude. So it's a very, very tiny wave. It's a short wave. The 1 is going to be represented by a tall amplitude. So then if we have 5 zeros in a row, we're going to have 5 little waves in a row, small amplitudes. And then we have a 1, which is going to be a high amplitude. So pause your video and see what you can do with this M. So the binary number is 01001101, a little more complicated than our A. So our binary wave will be a trough and a crest, and a trough and a trough, and a crest and a crest, and a trough and a crest. For our amplitude shift key, we will have a low amplitude, a high amplitude, 2 low amplitudes, 2 high amplitudes, a low amplitude, and a high amplitude. So we're just drawing the zeros as low amplitude waves and the 1s as high amplitude waves. That's what we call our amplitude shift key. The other one we're going to talk about is the phase shift key. This is where our bits are represented by shifts in the phase. So remember we talked about that wave shifting over. For a 0, we start at the equilibrium point and we start up. We go 1 complete up and 1 complete down. That's our wave. For a 1, we're drawing it in reverse. So we're going 1 complete down and 1 complete up. So you can kind of see how those waves look different because they've been shifted. So let's look at our A again. Okay, our binary number and our binary wave are the same. But when we encode them, the 0 will be a wave that starts at the equilibrium point, goes up and then down. So 1 complete wave. And then it goes down and then it goes up for a 1. Again, 1 complete wave, we just start down instead of up. So our zeros are going to be up and then down. So we have 1 complete wave that goes up and down inside that box. And then we have up and down, up and down, up and down, up and down. And then we get to the 1, and instead of going up and down, we're going to go down and up. So this is the phase shift keying. So look up the little g. Pause here. Look up the binary number for little g and encode that into PSK. So our binary number is 01100111. So we have a trough and a crest, and a crest and 2 troughs, and then 3 crests. So our encoded carrier wave, the first one is a 0, so we're going to go up and down. The next 2 are 1s, so we're going to go down and then up, down and then up. We have 2 zeros, up and down, and then 3 1s, down and up, down and up, down and up. So this is the phase shift key wave for the little letter g.